Hello viewers, in today's session we are going to discuss another application of beta and gamma functions, and in this class we are going to evaluate this integral where we have the integral from 0 to a x raised to 4 multiplied with the square root of a square minus x square. Right, so here we'll solve this integral with the help of some important results from beta and gamma functions. And first of all, we'll apply the method of substitution. Right, so applying the method of substitution reduces this integral into the beta function, that is beta m comma n, which is defined by this integral, that is 0 to 1, and we have t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. Right, so by method of substitution we'll first reduce this integral to the beta function. Right, so let us first take this integral as I, and let us substitute here. This x square is equal to a square t, right, so that we can take a square common. Okay, so now we'll take x square is equal to a square times t, so that x is equal to square root of a square t, and x can be written as a times square root of t. So now let us differentiate x with respect to t. So dx over dt is equal to a times the derivative of square root of t. So here a is a constant. So we have a times 1 over 2 times square root of t, because the derivative of square root of t with respect to t is 1 over 2 times square root of t. So now we can write dx is equal to a dt over 2 times square root of t. Right, okay, now let us change the limits. So here the limits of integration vary from x is equal to 0 to x is equal to a. So a is the lower limit, and sorry, here we have 0 as the lower limit and a as the upper limit. So when x is equal to 0, then we can find out the value of t from this expression. So t is x square over a square. So when x is equal to 0, t is 0 square over a square, that is simply 0. And when x is a, then t is a square over a square, and this is equal to 1. So when x varies from 0 to a, then t varies from 0 to 1. So now we can write this integral I in terms of t. So we have the limits t is equal to 0 to 1, and here we have x raised to 4. So we can now write x is equal to a times square root of t, that is a times t raised to half. So we have a t raised to half, and here we have 4. Then we have square root of a square minus x square. X square is a square t, and dx is given by a dt over 2 times square root of t. So now let us simplify this expression inside this integral. So we have a raised to 4, then we have t raised to 4 over 2, and here we can take a square common. So we have 1 minus t, and here we have a dt over 2 times t raised to half. Right, so now we can take here the square root of a square. So we have a raised to 4, then we have t raised to 4 over 2 minus half. Right, here we have t raised to half. So taking t raised to half to the numerator we have 4 by 2 minus half. Here we have a times square root of 1 minus t, and then we have a dt over 2. So now we can collect all these a's. So we have a raised to 1, a raised to 1, and here we have 4. So 4 plus 1, 5, 5 plus 1 is 6. So we can take a raised to 6 outside the integral. Here we have 2, and then here 4 minus 1 is 3. So we have t raised to 3 by 2 times square root of 1 minus t, and here we have dt. So now we can write a raised to 6 over 2, 0 to 1, t raised to 3 by 2, and 1 minus t raised to half, and here we have dt. So we can write here 1 over 2 for this radical sign, that is the square root. So now if we compare this integral with this one, then we have 0 to 1, and here we have t raised to m minus 1. Here we have t raised to 3 by 2. So we can now write m minus 1 is equal to 3 by 2, and here we have 1 minus t raised to n minus 1. Here we have 1 minus t raised to half. So n minus 1 is equal to half. So we can now write n minus 1 is equal to half. So we can now solve these two equations for m and n. M is 1 plus 3 by 2, that is 5 over 2. And n is 1 plus half, that is 3 by 2. Right? So now I can be written as a raised to 6 over 2. We have 0 to 1, t raised to 3 by 2. So 3 by 2 is equal to m minus 1, and m is 5 over 2. So we have 5 over 2 minus 1. And then we have 1 minus t raised to half. Half is n minus 1. N is 3 over 2, and this is 3 over 2 minus 1, and dt. So now this integral is exactly similar to this one, right? So we have here a raised to 6 over 2, and this integral is equal to the beta function, that is beta m comma n. M is 5 over 2, and n is 3 over 2. So now we have to find out the value of beta 5 over 2 comma 3 over 2. So now let us make use of the relationship between a beta function and gamma function. And the beta function is related to the gamma function by this relation, right? So we have beta m comma n is equal to gamma m times gamma n divided by gamma m plus n. So here we can now write I is equal to a raised to 6 over 2. Then we have gamma 5 over 2, gamma 3 over 2, and gamma 5 over 2 plus 3 over 2. So this is a raised to 6 over 2. Now see, gamma 5 over 2 and gamma 3 over 2 can be calculated by using this relationship, that is gamma n plus 1 is equal to n times gamma n. So gamma 5 over 2 is equal to gamma 3 over 2 plus 1. We can split 5 over 2 as 3 over 2 plus 1. Then we have this formula, 3 over 2 times gamma 3 over 2, and 3 over 2. Gamma 3 over 2 can be written as half plus 1. So we have 3 by 2 times half and gamma half, right? So this is 3 over 4 times gamma half. Gamma half is equal to square root of pi, right? Okay. So now we have gamma 3 over 2, and gamma 3 over 2 is equal to half times gamma half, that is half times square root of pi. So here we can now write 3 by 4 square root of pi for gamma 5 over 2, And for gamma 3 over 2 we can write half root pi, and in the denominator we have 5 by 2 plus 3 by 2. So 5 by 2 plus 3 by 2 is 8 over 2, and 8 over 2 is 4, right? So here we have gamma of 4, and gamma 4 is equal to 3 factorial, because we know that gamma n plus 1 is equal to n factorial for any positive integer, right? So gamma 4 is equal to gamma 3 plus 1. So we have 3 factorial, that is 3 times 2 times 1, that is 6. So here we have 6. So now here simplifying this expression, we have 3a raised to 6, and then root pi times root pi is pi, and here we have 2 times 4 is 8, 8 times 2 is 16 times 6, right? And then we have 3 times 2 6, and this is pi a raised to 6 divided by 16 times 2, that is 32, right? So viewers, the value of this integral is equal to pi over 32 times a raised to 6. Hello viewers, in today's session we are going to discuss another important problem from integration, and in this class we are going to evaluate this important integral where we have 0 to a dx over square root of ax minus x square, right? So in this class we'll solve this integral with the help of the concept of beta and gamma functions, right? And before applying the concept of beta and gamma functions, let us first apply the method of substitution. So let us first take this integral as I, right? Now see, we can also write this integral as square root of x times a minus x. So taking x common from ax and x square, we can now write square root of x times a minus x. So let us further write it as dx over square root of x times square root of a minus x, right? Okay, now we can write 0 to a, and here we have dx, and here square root of x can be written as x raised to half, and here we can write a minus x raised to half, right? Okay, now let us make the substitution, that is x is equal to a times t, right? So that t is equal to x over a. So let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of at, and a is a constant. So we have a times the derivative of t with respect to t, that is a times 1, that is a. So we can now write dx is equal to a times dt. Okay, now here the limits of integration vary from 0 to a. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 over a, that is 0, and when x is equal to a, then t is equal to a over a, that is 1, right? So now we can write this integral I as t is equal to 0 to 1, because when x varies from 0 to a, t varies from 0 to 1. And here for dx we can now write a dt, and here for x we can write at. So we have at raised to half, and here we have a minus at raised to half, right? So let us now simplify the integrand here. So we can now write 0 to 1. Here we have a dt, and from here we have a raised to half, then we have t raised to half, and from here we can take a common. So we have a raised to half times 1 minus t raised to half, right? Okay, so now we have 0 to 1. Here we have a dt, and here we have a raised to half and a raised to half. So this is a raised to half plus half, that is a raised to 1, that is a. So here we have a, and here we have t raised to half times 1 minus t raised to half. So now we can cancel this a and this a. So we are now left with 0 to 1, and here we have dt over t raised to half and 1 minus t raised to half. Right, now let us take both these terms to the numerator. So we can now write I is equal to integral 0 to 1, and we have t raised to minus half, and here we have 1 minus t raised to minus half and dt, right? Okay, now let us convert this integral into the beta function, which is also known as Euler's integral of first kind. So we can now write t raised to minus half as half minus 1, because half minus 1 is minus half, and here also we can write minus half as half minus 1, and here we have dt, right? So now we can see that this integral is similar to our beta function, that is beta m comma n is given by 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. And this integral is similar to this one. So if we compare both these integrals, then the value of m is half and the value of n is also equal to half. So this integral I is now equal to the beta function, that is beta half comma half. So now we have to find out the value of this expression, that is the beta function, using the relation between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So here I is equal to beta half comma half. So we have now from this relation gamma half, then we have gamma half, and then we have gamma half plus half. So now the value of gamma half is square root of pi. So here we have square root of pi, here also we have square root of pi, and here we have gamma 1. Half plus half is 1, and the value of gamma 1 is equal to 1. So here root pi times root pi is pi, and gamma 1 is equal to 1, so this is equal to pi. So the value of this integral I is equal to pi.